Okay, I'm doing U12.MFFMC3, which is Unit 12, Magnetic Field Forces on Moving Charges, Problem 3. In this problem, it asks us to derive and apply the formula for the radius of the circular path of a charge that moves perpendicular to a uniform magnetic field. So for this, I have an example problem that'll cause us to need to do this. In my example problem, it says a proton with a mass of 1.67 to the negative 27th kilograms and a charge of 1.6 to the negative 19th is moving in a circular path perpendicular to a uniform magnetic field with a speed of 1.6 times 10 to the 7th meters per second. If the magnitude of the magnetic field is 2.3 times 10 to the negative 3 Tesla, what is the radius of the proton? For this, we have two equations. First, we have force equals mass times velocity squared over the radius. And then we have force equals charge times velocity times magnetic field. If we set these equations equal to each other, because they both have the force, we can do this as so. Here, the V's cancel out, and we get mv over r equals qb. Now if we're solving for the radius, then we want to switch it up around, times this by r, divide by qb, and you get mv divided by qb equals r. So now that we have our equation, we can plug in all of our variables. So we're going to use mv over qb equals r. The mass of this proton equals 1.67 times 10 to the negative 27 kilograms. The charge equals 1.6 times 10 to the negative 19th coulombs. The velocity, or the speed, equals 1.6 times 10 to the 7th meters per second. And the magnetic field equals 2.3 times 10 to the negative 3 Tesla. With all these variables and amounts, we can find what the radius is. So the radius equals 1.67 times 10 to the negative 27 kilograms times 1.6 times 10 to the 7th meters per second. And this is divided by 1.6 times 10 to the negative 19 coulombs times 2.3 times 10 to the negative 3 Tesla. Now if we plug all of this into our calculator, we get, this is going to take a minute, When we do all of this, we get 72.6 meters. And there is the radius of the proton.